All right, guys, so we stopped at completing the square yesterday. We're going to look at the quadratic formula today. And again, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This here is the quadratic formula. So for 26 and 27, we're asked to solve each equation by the quadratic formula. So we're using the quadratic formula to solve. Which one do we want to look at? 26 or 27? 27. Now, when using the quadratic formula, we need this equation equal to 0. We need it equal to 0. So what we can do here is add squared to both sides. Because if we add 4x squared to both sides, we get 4x squared minus 7x plus 6 is equal to 0. Now that we do have it equal to 0, we can go on and use the quadratic formula. Let's go and put that over there. Now again, this is all referring back to the equation ax squared plus bx plus c. So we go to plug this in. So the first thing we have is negative b. Well, what is the value of b for our equation? It would be, so negative b would be positive 7, because negative 7, the negative and negative make a positive. So we can just write it as positive 7. Now inside the square root, we would have parentheses, negative 7 squared minus 4 times a. Well, a is 4 and c is 6. And this is all over 2 times a. Well, a is 4. And 2 times 4 would give us 8. So the only real things that we simplified at the same time when plugging it in is the negative b into a. Because 2 times 4 is 8. And negative b, well, negative 7 is just positive 7. Now, our next thing that we would do is we would type in to the calculator. I would type in everything that's inside the radical. I wouldn't include the radical. I would just do parentheses, negative 7, close parentheses, squared, minus 4, parentheses, 4, close parentheses, 6. And just do all of this in here. Because if it works out, if we do this in the yellow calculator and what's inside the radical turns out to be negative, it won't solve it. So we'd have to retype it all back in without the square root to try to get it that way. If we type it like this into the graphing calculator, which will take negatives inside the radical, but it works out to not simplify all the way down, and then it's going to turn it into a decimal, and we're going to have to do it again anyways. So it's better to go on and just type this in from the start. Now if we type this in, we get what? It goes 49. It is what? Negative 47. And I do that about every time I write with a highlighter. Negative 47. So if we had typed this into the yellow calculator, it would have given us an error because it cannot have a negative inside the radical. But we do know that whenever there's a negative inside of a radical or a square root, it's going to come out as I. And well, we're left with square root of 47. Because the square root of 47 will not simplify any further than that. And that's it. Any other questions on 26 or 27? If we're good with that there, we'll look at the next set. Now, find the value of the discriminant, describe the type of solutions, and find the values of the solutions. Now, on the test, I'm not going to ask you to find the values of the solutions, or essentially find out what the solutions to the quadratic equation are. And that's mainly because, I mean, a majority of this test is already solving quadratics. So adding that onto this here isn't really adding anything to what y'all learned or know. That's most of the rest of the test. So mainly what it's going to ask on the test is to find the value of the discriminant and describe the type and number of solutions. And we'll go through and I'll exactly show you what that is. Now, whenever we talk about the discriminant, there's three possible cases that we can have. It is that b squared minus 4ac can be greater than 0, which means we have two real solutions. It could also be that b squared minus 4ac is equal to 0. So we have one real, and I would add unique solution to it. Or we have b squared minus 4ac is less than 0, which means we have two complex solutions. It's going to be one of these three. Now, we'll never have a case where we have one complex solution, because by our property of, or our theorem of the complex conjugate theorem, it states that if a plus bi is a solution, a minus bi must be a solution as well. And in the one case where we do have one real solution, well, it was the same number. X is equal to 1 and x is equal to 1. They're the same thing. So with complex, they're always going to be different. A plus bi and a minus bi. Those are two separate terms. So these are the three that we can have. Now, do we want to look at 28, 29, or 30? Mm-hmm. Now, whenever we do any of these here, we need it equal to 0 so we can know the, not just the value of it, but the sign for A, B, and C. So we have the correct signs when plugging it in. What we can do is we can subtract 24x from both sides. And when we do that, we'll get 0 is equal to. Well, I'm going to rewrite this or change the order up a little bit because we want the variable with the biggest exponent to go first, which would be our negative 3x squared, because it's always going to go x squared x and then our constant term. Because we're basing it off the ax squared plus bx plus c, might as well get it in that same format. So we move the negative 3x squared up front, and then we'd have minus 24x minus 48.
So why isn't the 24 first?
We could put it first, but we like having it, or in standard form, it's going to go x squared x and then the constant term.
Oh, yeah, okay.
We want it written with the variable with the highest exponent first, and then decreasing order. And really, with this here, we'll only really deal with x, only one variable at a time. If there's multiple variables, it's still highest to lowest exponents, alphabetical order. So if a was a variable included in this and it had the biggest power, it would go first, and then whichever x, and so on. Now, we're going to plug this into our b squared minus 4ac. Well, b in our case is negative 24 and squared minus 4. A will be negative 3, and C is negative 48. Now at this point here, I just plug it into a calculator. Negative 24 squared, because if we, well, I can't, it'd be challenging to do this by hand because 24 squared would work out to be 576. Negative 4 times negative 3 times negative 48 would be negative 576. And this works out to be 0. So the value of the discriminant is 0. Because, I mean, we could, as I just did, I worked it out in parts. I did the negative 24 squared, found out what it was, and then did the negative 4 times negative 3 times negative 48, found out what it was, and subtracted. Well, if I'm already typing pretty much the whole thing into the calculator, might as well do it in one step. Might as well just type the whole thing in and have the calculator tell it's 0. You're doing the exact same thing, it's just doing it in parts. Now, since the discriminant is 0, what does that tell us? We have what? One real solution. Because when the discriminant is equal to 0, we have one real solution. Now, as I said, the test, the way it's going to ask it on the test is to define the value of the discriminant, which here would be what? 0. The number of solutions, well, how many solutions will we have? And the type is? Real solution. That's all it's asking for. Number and type, well, we're going to have one real solution. And that's all it's asking for. I'm not going to make you solve these here because you're already solving a good portion of the first part of the test anyways. Doesn't add anything. Any other questions on the other two for discriminant? We're good with this here? Okay, that brings us to finding the value of C. Well, C is equal to what? B over 2 squared. So for like 31, we can say C is equal to, well, the value of B here is negative 24. Well, negative 24 divided by 2 is negative 12, and negative 12 squared is 144. So we can say x squared, not plus, minus 24x plus 144 is our equation. Now, if we factor it, we're going to have x what? Because the number that goes in there with x is going to be what inside the parentheses whenever we square it, before we square it, so it's going to be x minus 12. And that's it. Because again, the question asks for find the value of C and find the factors, or find it factored. Because create a perfect squared trinomial by factoring, or finding the value of C and factor it. Well, what was the value of C? The value of C was, and it factored was, yes. Because that's all I'm really looking for. Now, if you didn't do write out, as we did for C, C is equal to negative 24 divided by 2 squared, and write it all the way out to get to a number, that's fine. But, and if you wrote it this way instead, that's fine, because it still has the value of C written. If you don't have C's value written anywhere, you just have it as x minus 12 squared was the only thing you included, I'm going to count all points for not finding the value of C. That's half the question. So on 32, well, you could have plugged it into the calculator as 29 divided by 2 squared. I do not know 29 squared off the top of my head. And had 841 over 4, comma, x plus 29 over 2 squared. I mean, because if it makes sense on how you figured it out and you just want to put that there, that's fine, because C would be 29 over 2 squared. because 29 squared is 841, 2 squared is. Because if you write it out, awesome. If you don't feel too comfortable with making sure you did the correct square, go on and write it out. Because then I'll be able to see where you had the slight miscalculation. But because if we work out 33, well, C is equal to, for this part, because we do B over 2 squared. Well, B is 49. Now, on the answer key, I did write it out as a decimal. You can write it as a decimal or leave it as a fraction. Either one works. Because if we leave it as a fraction, 49 squared would be 2401. So that's the value of C. Now our set of parentheses squared is going to be x plus 49 over 2. Because again, the number that we plug inside the parentheses for our factored form is going to be whatever the number is inside the parentheses before we square it to find the value of C. Questions on this here? Are we ready for the next part? Turn the page. So again, I wrote the review sheet up originally and realized I left this out, the addition, all the stuff with I, and I wanted to include it on the test, so I stuck that at the end. Eventually I will rewrite the review sheet so that fits, but I think it works just as well with it stuck right there at the end. The first part here is simplifying I terms for I to the n. Well, for any power of n, if we take that power and divide by 4, if the decimal is 0.25, it's going to reduce to I. If the decimal is 0.50, it reduces to -1. If it's 0.75, it reduces to -I. And if the decimal is 0.00, it reduces to what? 1. So Caleb, pick one of these that you want to see worked. I have a feeling once we do 1 or 2. B, 287? Well, it's 287 divided by 4.
Hold on.
So we're not concerned with the 71, but the 0.75. What does 0.75 line up with? So B reduces down to -I.
Do we always do 4?
Because these are the 4 possible outcomes that we can have. So we divide by 4. Let's do, Jalen, did you want D or E? E. 6971 divided by 4. Type it in, see what you get. Which is -I.
Yeah, I'm good with those now.
Try doing 71 divided by 4, see what you get. 71 divided by 4 instead of the whole number. Let's just do the last 2. So we get 0.75 still? Yeah. It works out this. So this came out with 0.75.
Oh, okay,
Yep. But since it's cyclic in how they show up, for any power of n, it's going to work out that if we divide that power by 4, 0.25 will be I. 0.50 will be negative 1. 0.75 will be negative I. And 0.00 will always work out to be 1. Now, we're not really worried about the whole numbers, because the whole number is just telling me how many cycles through these 4 numbers I went. What we're just worried about the decimal, because it's telling me in the current go round of these 4, where am I at? 0.75 tells me I'm on the third one. The third one is negative I. Questions on this here? Let's evaluate these expressions. Now with these here, you're not going to come out to a whole number answer. So when we evaluate each one of these expressions, we're not going to come up to a number answer. We're not going to have a single number. It's not going to be 14. Well, I take that back. It could be, but the I terms would have to cancel out. Because what I meant by that saying is that we're not solving for the value of I. We're not plugging something. We're just simplifying the expression. We're adding and subtracting. So when we look at this here, well, 6 plus 4, because those are both the real parts, would be negative 7i plus negative 3i would be negative 10i. That's it. 6 plus 4. Negative 7 plus negative 3.
Well, he didn't circle it.
Yep.
Smart person.
Guys, be nice. How about E?
So you do 189.
Parentheses. 189 second I minus 361 second I squared, close parentheses, plus open parentheses, 71 second I squared minus 38 second I to the fourth. So we can type the whole thing into the graphing calculator, and if we hit enter, so really we could have done any of these addition and subtraction problems there.
So did you say we could do any addition?
We can do any of the addition and subtraction in
That's all you gotta do.
the graphing calculator, yeah.
Dude, I'm not past this.
Because if we looked at this here, well, I squared is negative 1, so that'd change that to positive. I to the fourth is just 1. So we have 361 minus 38, 4. So we'd have 323, 189, oh, and this would be negative 1, so we still need to subtract 71 plus 189 I. So 2, let's see here, 3, 4, 5, 2. Because I believe the calculator said 252 plus 189I. but the calculator can do it for us. Any other questions with addition, subtraction? Questions on multiplication? H? So we do this here. So we can multiply by 2 first for the first two. 2 times 7 would be 14. 2 times negative 4i would be negative 8i. 3i times 7 is going to be plus 21i. And 3i times negative 4i would be negative 12i squared. Now the I squared is negative 1, so that would make that positive. And we'd have 14 plus 12 is 26 plus 13i. Because our negative 8i plus 21i would be 13i. Now at this point here, we can do the distributive property again. So 26 times 6 is going to be 6, carry the 3. 6 times 2 is 12, plus 3 is 15. 26 times negative 2i would be negative 52i. 13 times 6 is going to be plus 78i. And 13 times negative 2i is going to be negative 26i squared. Now the I squared would make that negative 26 positive because I squared is negative 1. Now 156 plus 26 is going to be 182 plus this here will be 26i. And we'd get this here. Can I borrow? Did we get the exact same thing? So we could have plugged this what? The graphing calculator will do it just fine. Because we just typed it in exactly as we saw it. For multiplication, division, we just type it in exactly as we have it. Now division, we can't type it in exactly as we see it. We have to change it a little bit. In that, so 8 minus 4i over 3 minus I. So to do that, 8 minus 4 second I divided by 3 minus I. So we have to write the numerator in parentheses divided by the denominator in parentheses if we're going to use division. And once we type it in like that, it will give it to us in decimal numbers. But we need to convert it back from a decimal to a fraction. And to do that, we would hit math, enter, enter, and it'll convert it back to a fraction that we want. So to do division, we write the numerator, we type the numerator in parentheses divided by the denominator in parentheses, enter, and then math, enter, enter, to return it back to a fraction. Any questions on these here? Okay. And really that's the rest of it is with division. Now the only other thing we have is the complex conjugates. Complex conjugates wasn't included on there, but it's not, I don't think, too terribly difficult. Do y'all remember what the complex conjugate of 7 minus 14i is? How about
So you just flip it.
16i?
It'd be negative 16.
And that's it.